Show that the perpendicular drawn from the points 4, 1 to the line segment formed by joining the points 2, -1 and 6, 5 divides it into ratio 5:8. So let us begin. So here we will start by considering a point A having the coordinates 2, -1. And then we'll consider another point B. So let's say B has the coordinates 6, 5. We're going to join point A and point B with the help of a straight line. Now we will consider another point, let's say point C. C has the coordinates 4, 1. We're going to drop a perpendicular from point C on the line segment AB. Now the perpendicular meets AB at the point, let's say D, such that D is the point which divides AB in the segment in the ratio lambda is to 1. So our goal will be to show that it's dividing it into ratio 5:8. Okay, now what we'll do, we will first find out the coordinates of point D using the internal section formula, because D is dividing AB into ratio lambda is to 1. All we have to do is take lambda and multiply it with B. 1 will get multiplied with A. So let's first find out the coordinates of point D. So here, to find out the x coordinate, we'll take lambda and multiply it with the x coordinate of B. So that's going to be 6 times lambda. Then add it to 1 times the x coordinate of A, so that's positive 2. We have 6 lambda plus 2 divided by the sum of the ratios, so that's lambda plus 1. And then to find out the y coordinate, we'll take lambda and multiply it with the y coordinate of B to get 5 lambda, and then add it to 1 times the y coordinate of A, so that's -1. So we have 5 lambda minus 1 divided by lambda plus 1. So this is going to be coordinate of point D. Now, the reason why we are obtaining the coordinate of point D, because we will be finding out the slope of the line CD. So let's find out the slope of line segment CD, and we're going to denote this by the letter M1. So this will be equals to, so the slope of a line is defined as the ratio of the difference of the y coordinate to that of the difference of the x coordinate. So to begin with, we'll consider the difference of the y coordinate. So here we will do the y coordinate of D. So that's 5 lambda minus 1 over lambda plus 1. And from it, we're going to subtract the y coordinate of point C, which is 1. So we have -1 here. Divided by, we'll consider the x2. So x2 will correspond to the x coordinate of point D. So that's 6 lambda plus 2 divided by lambda plus 1. And from here, we're going to subtract the x coordinate of C, so that's 4. Now, when you simplify this, we're going to get 2 lambda minus 1 divided by lambda minus 1. So this is going to be the slope of line CD. We can also find out the slope of line AB. So slope of line AB, which we will be denoting by M2, so that's going to be equals to, we'll take the difference of the y coordinate, so that's 5 minus -1, divided by the difference of the x coordinate, so that's 6 minus 2. This will be equals to, so 5 minus -1, that's going to be positive 6, divided by 6 minus 2, so that's going to be 4. So that means slope will be 3/2. Now, the whole reason we're finding out the slope, because we know by definition that whenever two lines are perpendicular to each other, then the product of their slope must be equals to -1. Fine. Now, since we have the value of M1 and M2, so we can replace M1 with 2 times lambda minus 1 divided by lambda minus 1, and M2 will be 3/2, and this will be equals to -1. Now, our goal will be to find out the value of lambda. So let's do that. 3 times 2 lambda minus 1, so that's going to give us 6 lambda minus 3 divided by, we have 2 times lambda minus 1, so we get 2 lambda minus 2, so that will be equals to -1. This means we have 6 lambda minus 3 equals to 2 minus 2 lambda, which implies we have 8 lambda equals to 5. Or simply put, lambda will be equals to 5/8, or we can represent lambda as lambda over 1 equals to 5/8. So therefore, we have successfully showed that the perpendicular line CD is going to divide the line segment AB into ratio 5:8.